Hi all, hope all is well. On today's video, I wanted to share the results of an experiment I have been doing using solar distillation. So I have been doing quite a few of these, and if you go back through my video history, you will find several of the videos on the subject. However, this one here was inspired in part by a lot of the commenters. So in one of my more recent videos I did, it was basically version 2 I called it. It certainly wasn't version 2, but we are calling it version 2. This will technically be version 3. And in version 2 we had a clear plastic jar over here, and we had a black coated jar on this side here. And the whole idea of it was to compare the two to see which one gave us better results. And it was conclusive that the black jar itself actually gave us better results, and it was better by ×3. So we increased our solar distillation rate by 3 just by changing it from a clear glass jar to a black coated jar. And what we've done in this one is we've taken it one step further. So what I should do before I continue is explain the process so everyone understands exactly what's going on here. But basically, if you have a look at the inner glass jar here, that was, we filled up full of seawater. And of course this one has charcoal added, so it's our variation. And this one here is just a standard glass jar with black coating on it. Now, the previous experiment just had the clear jar, as I said. So the idea is you put a clear glass jar of seawater inside the larger jar, as you can see here. And during the day, the heat and the light evaporates the water from the center jar, traps it in the capsule of the larger glass jar. So remember, it is seawater, so it cannot be consumed. And then it evaporates out, and it leaves all the heavy deposits behind. So all the salts and minerals and calcium and manganese and a whole variety of different salts are left behind actually in the inner glass jar. But the reason we wanted to do this was to see if we could produce copious amounts of drinking water. So eventually copious amounts of drinking water. Any drinking water was a start, and that's of course what we started with the plain glass jar. And then we stepped it up to the next level, which was the black coated jar. And of course, yeah, times it by 3 we went up, so pretty much. And then at night, what happens is during the day, it'll evaporate out of the inner glass jar. And then during the night and during the day, the cool air blows past the jar and it recondenses the moisture-laden atmosphere of the inner glass jar. So the inner jar here evaporates out, the atmosphere gets trapped in the big glass jar, the air blows past the glass jar, creating the right conditions for the atmosphere to reach its dew point. And at the dew point, that's when the moisture drops out. As you can see on the glass jar there at the moment, there's quite a bit of humidity in there. You can see it forming condensation on the walls, and then it runs out. And during the night and during the day as well, it runs down the edges and it collapses down the bottom here. So you can see there is quite a bit of water in there. And that is salt free. So it's been completely distilled, except for that rogue bit of charcoal floating around there. But it has been completely demineralized basically. So it's distilled water. Now the distilled water itself, if you get it cleaned enough where there are no minerals in it, which this will be, except for that little piece of charcoal, you can use it in like car batteries and stuff like that to top them up. That's what, you know, a lot of distilled water is for. If you go and have a look in the automotive shops, you'll often find distilled water bottled and ready for sale. They also use it in irons and stuff like that as well. It's another good way to stop staining your clothes while you're ironing. But for this purpose, we wanted to perform it so we could extract drinking water, as I've already said. And what I've done in this one, which was different, and it was suggested by a lot of the commenters, was to not only use the black glass jar, so we're going to use that as our new benchmark because we know that increased the rate by 3. But I decided to crush up some charcoal from my fire pit, and then using that charcoal from the fire pit, we ground it down into like a fine powder. And I didn't fill it right up. I literally crushed up about an inch's worth. So by the time I put the seawater in it and then I crushed the powder up, I put the powder into the jar. It was sitting on the top for about an inch thick. And I knew, I'd probably get better results if I just filled the jar up completely and then added the seawater to it. That could be for a later video. But for this demonstration, I just wanted to keep it as simple as what you see here. And what you can actually see is that the charcoal unit, the charcoal solar distillation unit versus the black coated one has visible improved results. Now, I started doing this on May 15th and it is now May 25th. So for 10 days this unit has been running, and I am well aware that maybe removing the moisture that's generated each day would improve a drier atmosphere in the jar, which would allow more moisture to get humidified into the atmosphere, and then it would also allow more moisture to be condensated out, because we're not re-evaporating the distilled water unintentionally. Whereas if keep it in here like it is, you unintentionally re-evaporate that water every day as well, and the water in the inner jar. So what I'm going to do now is we're going to measure the results just to confirm how much the charcoal unit has improved the results by. And I do believe we will have to repeat it as well. It needs to be repeatable, so we can confirm for certain that the charcoal unit is the winner. So we'll go ahead now and take this unit apart. So if we were to hold that as level as possible, looking at 150 ml. Turn around this side just to have a look. Or half a cup, approximately, a little bit over half a cup. Okay, now to do the standard black coated glass vessel. That down there. Yeah, so at this stage it looks to be the black coated vessel that is winning all the way. We're at 2/3 there of a cup. Okay, so the results are conclusive. From what I've observed in running this experiment, even though this appeared to have more fluid generated from the solar distillation unit by using the charcoal instead of the black coated jar, we quickly discovered that that wasn't the case. So we got half a cup of water out of this one, while we got 2/3 of a cup of water out of this one. So the black coated jar is definitely the winner. However, in saying that, having charcoal in your water definitely helps to improve the evaporation rate compared to the standard variety. So if you recall, with the standard glass jar, we got 1/3 of it. So if we got 300 ml out of the black coated jar vessel, then we only got 100 ml out of the clear glass jar. So even though it is pretty rudimentary, adding charcoal to your seawater definitely helps to improve the evaporation rate, but not quite as well as it would if you had a black coated jar to do the work for you. So I think the next step we need to do now is I'm going to crush up more charcoal, and I'm just going to leave this salt water as it is in there. You see the levels are getting fairly low. It is true in both of the units. Even this one here, you can see they're both getting fairly low. So what I'm going to do is I'm going to actually fill this full of charcoal. I'll crush up a heap more, and that will be an experiment for the next video to see if I can improve the evaporation of the charcoal unit. And that's it for today's video. I hope you enjoyed. I hope you got something out of it that's potentially useful. It may not be useful now, but you just never know in the future. If you enjoyed it, please give it a thumbs up. Please put your comments and suggestions in the comment section below. I appreciate all the feedback I can get. And you never know, one of your suggestions may even be on one of the future videos as well. Thanks again. Cheers. Bye.